Okay, this lesson is going to be on aircraft geometry. I'm assuming that there's some basic knowledge that you will all have, but we're going to start assuming that you don't know any of the terminology for an aircraft. We're going to talk about, when we say aircraft geometry, it's really just the parts of the plane. And then we're going to talk about how those plane parts, especially the parts that are controlling the aircraft, which are called control surfaces, what they do and how they do it. Okay, so quite a bit to get through in this lesson. So, I'll just put a title up here, Aircraft Geometry, and I'm going to put in brackets there, parts. Okay, this first video we'll probably talk about the parts rather than how they control, because it'll be too long otherwise. I'll be nattering on for an hour. And the next video will be how those surfaces control in a more in-depth way. Okay, so aircraft geometry. So we can draw an aircraft probably in top view to show a lot of the parts. Okay, top view of an aircraft. Some of these parts you'll obviously know, okay? So fuselage is basically the main body of the aircraft, okay? You know, carries cargo plus passengers, etc. Okay, main body. Okay, obviously where our pilot sits is called cockpit, or on a larger airliner it might be called the flight deck. Propulsion for this aircraft is a propeller. It could also be a jet, and then obviously wing, and then inside the wing we've got these surfaces, okay, that can be adjusted. Usually on this aircraft, not always, but most often you'll find that this these two surfaces here are called the flaps. And basically what they do is they increase the camber of the wings. So if the wing's at an angle of attack like that, what they do is, and the airflow is being directed downwards, what they do is they extend, usually they quite often extend, in some aircraft they'll actually, you'll see them on jet airliners actually extend out and down. But on this type of aircraft, a simple aircraft, there's just a hinge in the wing and the flaps will go like that, effectively increasing the angle of attack and the amount of lift, okay? So that's a way of increasing lift. Now, we do that because as the aircraft is increasing its angle of attack, as it slows down, so the aircraft is slowing down, the wind going over the wing is slowing down, we start to lose lift. So if we want to travel at a slower speed to approach the airport, because we don't want to land at cruising speed, it's too quick, what we need to do is slow down. But if you want to slow down, we also want to maintain lift. Now you can increase the angle of attack on the wing, so you can pull the nose of the aircraft up so that you've got more of an angle of attack. That will increase lift. But at some point in time, if you increase the angle too much, the wing will stall, okay? And basically what stalling means is, if you have a wing and the wind is hitting it this way, we've said in our description of lift that it follows the surface. Flow turning, okay? Now if you increase that angle too much, what will happen is the airflow on the top of the wing will separate away and you'll get turbulence on top of the wing. Now that is going to cause parasitic drag and a loss of lift. So when you do your pilot training and you want to stall the aircraft, you throttle back to slow the aircraft down. You sometimes go to idle, and then you'll slowly pull back, because as the aircraft starts to slow down, if you want to maintain altitude, you can just keep pulling back and pulling back, generating more and more lift. But at some point in time, that happens and the aircraft drops. Okay, so a way of having a slower speed without stalling is by dropping the flaps. So when you reach a certain speed on approach, you can't throw the flaps out at cruising speed because it's too much wind load on the flaps as they drop. But when you get to the right speed on a light aircraft, there's normally a white arc in your airspeed indicator. You will throttle back, and as you approach that speed, you can start throwing out the flap. And what that does is it allows you to cruise at a slower speed and still generate enough lift. Okay, so if I was to draw the wing as it normally looks from the side, this is a cross section. Okay, your wing is going across this way. When the flaps come down, what they do is these flaps, which are here, are going to appear in that position. Okay, and what that does is it effectively makes the wing, instead of being curved like that, the wing's now curved like that. Okay, it's a lot steeper curve, and what that does is it increases lift. It also allows you to have a lower nose attitude, and the attitude of an aircraft is the position it's in. So it allows you to have a lower nose attitude at a slow cruising speed. So if you wanted to maintain lift and you're coming into land, the aircraft is going to have a high nose attitude. You can't see the runway properly. So you throw out flap, which means you can travel slower at less of an angle of attack, okay? Which means the runway is more visible. So that's another reason. Increasing lift at slow speeds and lowering the nose attitude for approach and landing, okay? That's how your flap works, okay? So you would throw out both of these flaps on approach to land, and so that's a flap for you, okay? Your ailerons, okay, are how you control the roll and turn of the aircraft. So in an aircraft with a control yoke, turn it right, just like in a car, the aircraft will bank right or roll right and do a right hand turn. Turn left and the aircraft will go left. How does that work on the wing? So we talked about flaps. Let's talk about how those control surfaces control roll for a turn. Okay. So if you were to look at the wing or the aircraft from front on, what happens is our ailerons, which are on the outside of the wing, one will come down and one usually goes a little bit up, okay? There's a reason for that one going up, and we'll talk about that another time. I don't want to confuse you, but when that one goes down, it's just like when the flap goes down, it increases lift. So if this wing has increased lift on it, okay, the aircraft is going to roll that way, okay, because it's pushing up more than this wing, okay? Now if we, so that would be, if we're going to roll left, so we'd be turning the wheel, our pilot would be sitting in his little cockpit and it'd be turning the wheel that way, okay? This is if we're facing the pilot. Okay, so he's turning the wheel, the aircraft is rolling and doing a turn to the right, okay? And if he turns the other wheel the other way, if you were to turn the controls this way, this one goes down and this one comes up a little bit. And we bank the other way, okay? Bank or roll the other way, okay? So that is what your ailerons do. That's the control surface, the ailerons. I said I wasn't going to tell you how they all work, but it seems that I'm heading down that track, so we'll keep going. So we know obviously what the wing does, it generates lift. We know what the propeller does, it produces the thrust for forward motion. This area here that contains the motor, the covering for it, it's sometimes called an engine cowling, okay? Which is like an engine covering, or I've seen it referred to, and it's referred to this in as a nacelle, okay? engine nacelle. Okay, either term is usable. So we've done our roll. Now, basically an aircraft has a series of control surfaces that allow three-dimensional manipulation of the aircraft in when it's flying. Okay, so we've done rolling. Okay, so I want you to all stand up. Come on, get out of your seats. Stop playing on the games. Patrick, I can see you. You're not doing the work. Get out. It's not just you, Patrick. I know. Everyone's doing it. Yeah, I know. Get out of your seats. Okay, so I'm an aeroplane. Okay, we're all aeroplanes. If I want to increase lift, pretend our hands are the flaps, but they would normally be inboard on a light aircraft. If I want to increase the lift and slow down, I start putting the flaps out. Okay, that means my nose attitude can be a little bit lower and I can see the runway. That's how flaps work. Okay, now let's stand up and pretend that we are going to roll to the right. Okay, we're going to turn to the right. What would happen is you would turn your control column to the right. This aileron would go down. If you're doing this in pre-flight checking too, you'd be like doing this to make sure you had correct, what they call correct sense on all the control surfaces. Turn right, make sure it does the right thing, rudder pedals, everything. You check them all. Anyway, I digress. So we're going to pretend we're going to the right. Which hand is going to go down? This one, because we want to increase the lift on this wing. Okay, so by going down, we've increased the camber of the wing and the angle of attack. As long as the wing doesn't stall, and it's designed so you can't stall it, it's going to get right to the right. Now you also get a little bit of up on this side. Okay, so when one goes down, the other one goes up a little bit, and we turn to the right. I'll explain why that happens later. Okay, if we want to go to the left, this one goes down and this one goes up a little bit, and we turn this way. Okay, so that is how your ailerons work. Anyway, ailerons is done. The tail of the aircraft is also called, this bit here, the horizontal bit, is called the horizontal stabilizer. So what's going to happen is most of your weights in the aircraft is going to be, or the engine, or sorry, the weight of the whole aircraft, the center of gravity is normally going to be a little bit ahead of your lift. So it's going, if your lift is here going up and your center of gravity is here, the aircraft is going to tend to pitch down. Your aircraft is going to want to do that, okay? Because weight of the engine is pushing down, and behind it you've got your lift vector. So this is going to happen. We'll talk about this when we talk about forces in flight. But the way the aircraft is normally set up, it's going to want to pitch down. So you've got this horizontal stabilizer stabilizing by creating an opposing force. So it's actually pushing down rather than up like the wing does. So if the wing's pushing up, horizontal stabilizer is set up so that it's pushing down. So instead of having an angle of attack like that, which would create lift, it's actually probably a little bit like that. Okay, so we end up with, as the name implies, stabilization. So you can fly straight and level and not nosedive into the ground. Okay. Now at the back of our horizontal stabilizer, we've got a thing called the elevator. Okay, so if I was to draw a side-on view of the aircraft, I'm just recording. Say hi, Tim. 1.5 meters, 1.5 meters. Okay. Horizontal stabilizer. So we've talked about what that does. On the back of it, you've got a thing called an elevator. Okay, so if I was to draw it from a side view, what it would look like is kind of like that. And okay, this part here can move up and down. Okay, so if that's your stabilizer, the elevator is at the back and it can move up and it can move down. Okay, what do you think that does? it is at the back of the aircraft, and it's called pitch control. So when we're talking about, let's all get up again. Let's pretend to be pilots again. Okay, so that's my elevator. Okay, it goes right across the back of the horizontal stabilizer. So you can see here, this part here, all of this at the back of the horizontal stabilizer is hinged, so it can move up and down. Okay, and I'll try and put a video under this of all these control surfaces. I'll find a good one online. But it moves up and down. Okay, so let's pretend that our hands are the stabilizer, the horizontal stabilizer. Sorry, the elevator on the horizontal stabilizer. Okay, so I'm in the aircraft. If I want to bank right, when we talked about ailerons go right, ailerons go left. When you're controlling the elevator, there's only two things you can do. You can pull back on the stick, or back on the controls, or you can push forward on the controls. Okay, so our ailerons allowed us to roll, and our elevator allows us to, if we pull back, the aircraft goes up. If we push forward, it pitches. It's called pitch. Okay, ailerons are for roll, and I'll write this all at the end. We'll summarize it. Ailerons for roll, and our elevator is for pitch, nose up, nose down. Okay, so we've done roll, we've done pitch, down, up. There's only one more thing left. Okay, and it is called, it's got a strange term, yaw. Okay, so if the aircraft is flying straight and level, you can roll, you can pitch, or you can yaw. And yaw, I'll show you a top view of yaw. Yaw is doing this. Okay, it's not pitching up or down, it's not rolling from side to side, it's just shimmying from right to left. Okay, it's not rolling, it's just doing that. Okay, so that's a roll, that's a roll, that's a pitch, that's a pitch, and this is a yaw to the left and a yaw to the right. Okay, so that's the difference. Okay, so it's in 3 dimensions basically, on the horizontal, on the vertical, and there's another axis, the Z axis. So 3-dimensional movement of the aircraft. Okay, now how do we achieve that? It is done with a thing called the rudder, and the rudder is on the vertical stabilizer. Okay, so I'm going to rub this out. We've done our elevator on the horizontal stabilizer. On the back of the aircraft, we have our vertical stabilizer. Okay, the tail. Okay, vertical stabilizer, and at the back of the vertical stabilizer, you've got this thing which is just like the elevator, same deal, and it's hinged. Okay, so it can turn, it can hinge to go that way, or it can go the other way. So if you were to look at the back of your vertical stabilizer, it does that. And if you turn to the, and now you're going, okay, but that's a roll, and that's a roll. How do you control that? Well, believe it or not, it's not bad enough that you have to go up and down and right and left. Pilots also have 2 pedals, okay? Tops of the pedals, normally there'll be a brake that you can touch. You can actually differentially brake. You can brake the right wheel or the left wheel to help you turn. When you're going slowly, you're not going to do it when you're landing. You'll push both brakes when you're landing. But you've got 2 pedals, and so if you want to yaw to the right, you're going to push down on the right pedal. If you want to yaw to the left, you're going to push down on the left pedal. Okay, and that's going to allow you to yaw to the right or yaw to the left. Okay. It's also, the pedals are also used on the ground when you're taxiing to steer the aircraft as well. So right and left yaw is just the rudder on the vertical stabilizer and changing its direction. So looking from behind the aircraft, it would either stick out to one side or the other, depending on which way you were trying to yaw the aircraft. So that is your rudder. So that's basically all your control surfaces for the aircraft, okay? Now, how many minutes are we in? We're in 20 minutes. I'm going to very, very quickly, this is almost half a lesson to explain these things, but there's a lot to it. So it's nice to understand how it all works. When you're rolling to the right, what happens is the aircraft wants, normally if you do a turn, you want to turn to the right by rolling to the right, and you want the aircraft to the nose to point into the turn. Okay, it kind of makes sense. You don't want the aircraft to be turning to the right, but the nose doing that. Okay, body across the airflow, because it's not a very comfortable feeling and it's not a very good turn. So it's what's known as an unbalanced turn. Okay, it just feels really yucky. Okay, so when you normally, if you've got an aileron, if I was sort of banking to the right and I just drop this one down, okay, I'm increasing the lift here, which is great. So I'm going to start to roll. The only trouble is I'm also increasing the drag on this side. So if this wing's slowing down, even though I'm rolling this way, I'm going to yaw that way. Okay, think about it. Increasing lift, but increasing drag as well. It's not as aerodynamic. Okay, so when I turn that aileron down, because when I want to roll to the right, I'm increasing drag. So I'm going to do this, and that's called adverse yaw. Okay, an adverse yaw, just write it up here, is a real problem because when they first started designing aircraft, it's also called a Dutch roll if you're a pilot. An adverse yaw basically means that you want the aircraft, if you're rolling this way, you usually roll in that direction if you want to turn in that direction. But you want the nose to point, if I'm rolling to the right, I want my nose to point into the turn, not out of the turn, okay? For obvious reasons. It's not going to be a very comfortable or a very effective turn. So when I drop this aileron down, okay, to make the turn happen, to make this roll happen, this wing is going to drag more, so it's going to cause an adverse yaw. So what do you need to do? You need to compensate for that drag. So what they do is they pop this one up a little bit, okay? So it's differential, what they call differential ailerons. And so that one pops up a little bit, so it's going to create drag as well. And that's a way of compensating for that adverse yaw. Okay, and that's why when you operate your ailerons on the aircraft, one goes down, one goes up a little bit. Usually not as much, because it would create too much drag. And if you're doing a pilot's license and you do a right-hand turn, there's a little ball in a tube that you try and keep in the center. And so if the ball starts to go off to the right, they say you step on the ball. So you use your rudder pedals to keep the turn balanced, okay? Probably too much information, but at any rate, if you're turning it to the right, you'd normally apply a little bit of right rudder pedal just to make the turn nice and balanced, okay? Aircraft that are designed really, really well these days usually don't have to put too much rudder pedal in, but in the bad old days, if you wanted to keep a turn balanced, you had to roll to the right and really, squash the right rudder pedal to make it happen, okay? So differential ailerons has allowed you to get rid of that adverse yaw, okay? So that's why they're differential. Don't worry about too much about that if you don't understand that adverse yaw stuff, but you do need to understand that ailerons, okay, let's do the summary now at the end of this lesson. We'll see if we can keep it to half an hour. Okay, so ailerons control roll. Okay, so to the right or to the left. And our elevators, which are on the tail, control pitch. So we draw an aircraft from the side. If this is going down, okay, it's going to increase lift and the aircraft is going to pitch down, okay. If it goes up, like that, the aircraft is going to pitch up, okay, because the airflow is going to do that. Okay, so that's elevators controlling the pitch. Okay, so we've got ailerons, elevators. The last one, so the last one was yaw. So I will put it over here, yaw. Okay, so yaw is just your rudder pedals, which you control with your feet. Okay, and it's held inside usually that vertical stabilizer. Okay, so, and it's called the rudder. So rudder controls yaw. Anyway, I've got a phone call. That's the end of the lecture. Any questions, send them to